Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Herb Lechner, sort of sitting in for Gary Kildall this week. Not really. Gary's going to be with us, but on the other side of the table today because our subject is operating systems. And as you may know, Gary Kildall is the creator of CP/M, perhaps the major operating system in use today. Herb, operating systems is kind of a tough subject because as computer users, we all deal with operating systems, but frankly, not very many of us really understand what it is. Give us a brief general introduction to an operating system.
Well, Stuart, I guess operating systems are most exciting when they don't work, and that you don't want to have happen. But on the small machine side, operating systems manage the computer resources, and they save the programmer a tremendous amount of nitty-gritty effort, and they provide a standard operating environment to enable applications to run on different machines and on different configurations. On the large machine side, operating systems become very sophisticated and literally manage the computer resources in such a way that they can achieve their potential.
Okay, before we get to Gary and our other guests, we're going to take you inside a computer to see exactly what the operating system does.
Hello, can I help you?
Yeah, where are we?
Well, you're standing inside an Apple IIe microcomputer.
And who are you?
Well, I'm Bruce Tognazzini. I'm an engineer with Apple Computer, and I'm here to check out and make sure everything is perfect on this computer because we have a report that in just a few seconds here, one of our owners is going to be turning this computer on.
And what is all this stuff?
Well, these are the parts that make up an Apple computer. That particular chip that you're standing on
is
called a microprocessor, and it's pretty much the heart of the computer, kind of the moderator of the talk show that goes on. And these two chips down here, these are very important ROM chips, which have the built-in basic language and the very kernel of the operating system. And then these 8 chips out here are the RAM chips, and they hold the information that comes in from the disk drive and that the user types and the programs and so forth.
Bruce, we're trying to figure out what an operating system does, and maybe you could help explain it.
Well, sure. An operating system essentially runs the entire computer once it's come in, but right now it hasn't turned on all of it. I see the user's about to flick on the switch. It's all right. It's only about 12 volts. The power light goes on, and then the little microprocessor here has the job of checking itself out and then turning control over to this ROM chip. This ROM chip, in turn, has a very small program which goes back to the back of the computer and checks out and sees whether it can find a disk controller card, which of course it can because there's one plugged in here. And on the disk controller card is another ROM, and this ROM now takes control from that one and begins to bring in the disk operating system off the disk drive through this white cable. You probably saw the disk drive while you were on your way in here. And then that comes down and starts filling in these RAM chips here. Fills up about 1/5 to 1/4 of the RAM chips with the disk operating system. It brings in any language and perhaps any program the user wants to do. And after about 15 to 30 seconds, it's all done. The screen gives a message to the user, and then the user can go to work.
Okay, well, I've got to get back to the Computer Chronicles. Thanks a lot.
Certainly. Thank you.
The operating system is a sophisticated computer program that makes the computer easier to use and operate more efficiently. Operating systems are sometimes called system software or systems programs, as contrasted with application programs, which are the subject of a later lesson. Operating systems provide up to 7 functions, not all of which are present in smaller computer operating systems. One function of all operating systems is to establish the way users interface with the computer. For example, how data are stored on files and how programs are initiated. A second function of operating systems is to permit multiple users to share the same hardware. A third function is to manage data files so that data may be shared among several users or applications. Potential users can be scheduled and unauthorized access prevented. A fourth important function is the handling of all input and output data. Since many applications will run on the computer and share its storage devices, it is necessary to have a common control over how data is stored, accessed, and retrieved. A fifth function is to provide error recovery for the computer system. If an error occurs in the process of reading data from an input device, for example, the system will try to reread the data several times until the error is recovered or bypass procedures initiated. System accounting is a sixth operating system function. This function keeps track of the machine resources so costs can be apportioned among multiple users. How much CPU time is used by each application? How many disk and tape records are written and read by each application, and so forth. The last function provides maintenance accounting. It keeps track of correctable machine errors to aid the maintenance and replacement of failing components. Operating systems available for today's microcomputers are approaching the sophistication of the systems described here and are the subject of the video portion of this program. Gary Kildall shows one of his latest in the next segment. Let's join him now.
Joining us now is Gary Kildall, no stranger to this program, of course. Gary is the creator of CPM, host of Computer Chronicles, and also Chief Executive Officer of Digital Research. And with Gary is Tony Fanning with the Corporate Engineering Department of HP Labs at Hewlett-Packard, and Tony works primarily with MS-DOS. Herb?
Gary, in view of the immense success of CPM 80, could you tell us a little bit about how the idea got started and how it came to be what it is today?
Well, I guess I'm sort of known as an operating system person, but realistically, I started back in the early days of computing and mostly interested in programming languages rather than operating systems. And I was working with Intel Corporation, working on a language called PLM. It was used as in the early days of microprocessors, and it was necessary to have some kind of an operating system to support the language. And that's where the name came from. CPM was a control program for microcomputers, just as PLM was named a programming language for microcomputers. And we were using paper tapes at the time, and we needed to have something else to store programs on besides paper tapes. It was a pretty tedious process. And so floppy disks came around, and CPM was in the software that made those floppy disks usable in a small computer system.
Gary, operating system is a bit of a mystery to a lot of normal computer users who just take advantage of it but never really get to delve inside of it. Could you give us a rough description of what the operating system does inside the computer?
Well, basically there are three levels of software, if you want to think of it that way, that you work with in a personal computer. One of them is the level of machine instructions. That's just if you turn the machine on, you don't put any diskettes in, the machine is capable of understanding some instructions. Those are machine instructions. But you have to put something in there to make the thing operate. The second level is what is called system software, and that lies right above the machine language itself. And the third level is the application software, and that's what you actually go out to the store and buy, is the application software. And then the application software then uses the system software as a foundation. System software then runs the machine using the machine instructions. So in that middle layer of system software, you find a number of things like programming languages, utilities, and operating systems. Now, an operating system then is sort of the traffic cop. It keeps track of file, or how your files are stored, how your display is handled, and the keyboard is handled, and things of that sort. And so it's just the foundation for it's like a record player when you're playing records.
Well, you have the perspective as a developer, Gary. Tony, you're a user of operating systems. What, as a user, do you seek to find in an operating system?
Well, I have an interest, of course, technically in the operating system and how it works, but really when I'm using it, I want the operating system to be transparent to me. I don't want to see it. I just want to use an application, and I know you asked a question earlier about what should one look for? Well, what are you trying to do? If I'm trying to do something like, for example, word processing, I'd like the operating system to just disappear and not bother me.
Now, you work primarily with MS-DOS, Tony. How would that be different from, say, Gary's CPM?
In a lot of ways, it does the same types of things that Gary's CPM does. I think Gary can tell you about some variants of CPM which are very different from what MS-DOS currently does. That's basically the same thing. It allows you to take care of files, take care of transfer of data from one place to another. It takes care of the whole human interface between you, your fingers, the computer, the programs that run in it.
Gary, we've been through several generations now of, say, CPM, and each one adds something. Can you describe for us what gets added each time? How do you improve an operating system each time you come out with a new version?
Well, the real key to any system software is trying to match what you're doing with that software with the computer system, the capability of the computer system that you have. And what happened, I think, early on in the microcomputer days is that the big computer system had 16K of memory. And so the idea is to tailor down an operating system that uses only a very small part of that memory. Now, when you add more memory, faster processors, then you get more functionality that you add to the operating system as you do more for the operator. And what's happened with well, these 8-bit systems, for example, are all now 64K. Those are maximum memory size, and even in the 16-bit machines, the average memory size is let's say 128, 256, even 512K. We're moving in that direction. And so what happens is the operating system expands, gets more functionality to take advantage of that larger memory area.
One of the early attributes of CPM and some other operating systems were that they were simple and clean and neat. And now with the computers becoming larger and this growth occurring that you're talking about, are we going to see the sophistication and complexity grow in the operating system?
Well, it certainly is true that it's very easy to add what are called bells and whistles to an operating system, things that really don't add much to the functionality just because there is more memory space. And I think that's the real crucial issue, is how do you add the right kinds of functions. What we see now with 16-bit machines and large memory systems is that we'll see things like concurrency, and we'll be able to demonstrate some of that today. That is, large computer systems have had concurrent operating systems, or multitasking is what it's called in large computer business, for years, and that's the idea of being able to use a computer system to do more than one thing at the same time. But if you look from the small computer, microcomputer days on to today, you see what's happened is that we started with single tasking or single user systems. And so what's happening now is we're coming together, and concurrency, or the idea of doing your printing while you're doing your word processing, for example, is the one that we're finding in that additional functionality that's added.
Gary, you have, I think, concurrent CPM up here on the IBM PC right now. Maybe you could just run through a little bit and show us what the components of this system is.
Okay, now the idea of a concurrent system and concurrent CPM is it's what's called a real-time system. That is, it's able to switch between programs in very short time intervals, and, for example, be able to receive data over a modem while you're seeing the directory operation. Now, what I'm going to do here is I'll use the keyboard to switch between what we call virtual screens. That is, you can imagine now that you're looking at 4 different consoles as I switch from console to console. So if we say console 0 is the one that we're looking at right now, and that happens to be shown in the lower left-hand side of the screen. Console 1, you'll see, happens to be a display of memory locations. Console 2 that I switched to happens to be a directory, and console 3 is a brand new free screen. Now I'll start a command here. I'll start a debugger just to get something going. And it's loading off the disk, and it's also giving me the prompt telling me it's ready to go. Now I'm just going to say display all of memory, so we'll have something active going on there. Now while that's going on, I'll switch back, and you can see that we're in a directory operation here. And so I'll just start that one again on this console. And as it's going, I better type it right here. That seems to be the weak point in the system, is the operator. And then as this is going on, I'll go ahead and switch back, and we can see what now we're getting a display of the directory right now, and I'll switch back, and you can see this other program is still actively processing. Okay, that's finished. Switching back again to the original screen. Now this is a very short demonstration of the concept of multitasking or concurrency, but the way it would actually be used, to say in a business, is that you'd have your word processor working on one screen, and then meanwhile you'd switch over to, say, another screen to do spelling checking or receive data over a modem. So the effect is that you get multiple microcomputer systems in front of you on your desk. Now this is the way that operating systems are moving right now. because of the fact we have, let's say, half a megabyte of memory in the machine, we want to make sure that we use that machine effectively. Because what we're looking at nowadays with computers of this type are really the mainframes coming down to your desk. So we want to make sure we have that capability.
Okay, well, Unix and Xenix may sound like two characters out of a Star Trek episode, but in fact they're two very elegant operating systems, and we're going to take a look at them in just a moment.
Operating systems for the larger computer systems evolved over time and were primarily used to improve hardware efficiency. Their main job was to keep the CPU and main storage as productive as possible, scheduling as many different users and applications through the hardware system as possible. One way this was accomplished was through multitasking or concurrency. This is the computer's ability to run several applications at once. Most applications, which use a fair amount of I/O, do not use the CPU efficiently. The CPU is frequently idle, waiting for the application program to get data from a slower I/O device. The operating system accomplishes multitasking by allowing an application program to run until it requests I/O. The operating system then suspends CPU processing for that application and starts another application, which continues until it needs I/O. The operating system will initiate as many applications as are needed to keep the CPU busy. When the I/O requests are satisfied, the operating system will reinitiate a suspended application. This is just one example of the types of relatively sophisticated function performed by the operating system. Unix, an operating system originally introduced for mini-computers, but which is quickly finding application in micros, is the subject of our next segment. So let's get back to our program.
Joining us now is Gene Yates, who's president of Yates Ventures, a company involved in research primarily involving the Unix operating system. Gene, welcome to the Computer Chronicles.
Thank you.
Tell us a little bit about Unix and what it is, especially compared to CP/M and MS-DOS, the other things we've been talking about.
Well, Unix is another of the standard operating systems that computer users are growing to find more interesting to them because of the variety of application software and different brands of computers that they can choose by going with a standard operating system as the basis of their computer system. And Unix is particularly unique because it runs on microcomputers, mini-computers, and mainframes, from the smallest to the largest systems, from an IBM personal computer to a great big huge Cray supercomputer. Unix is available for all of them. Unix is also very easy to network so that you can connect these different brands and sizes of computers together easily. And if both computers use Unix, you can find yourself sending electronic mail, transferring files, sharing application software programs very rapidly, more so than with many other products. Another major facet of Unix is that it's multi-user. That means that more than one user can access several different programs at the same time with Unix. So one person at a terminal into a computer could use an accounting system, while another person at the same time is doing word processing, while another person is sending electronic mail, each running a different application at the very same time using the same computer, just different terminals.
Gene, as I recall, Unix grew up in Bell Labs and then was for a while licensed only to universities and not-for-profit organizations.
Yes.
Is it fully commercially supported now?
Well, Unix has a long history, and it was first introduced in its most primitive form in 1969. It wasn't until the Bell system was deregulated, I think we're all aware of the big doings with ATT, that ATT could really sell and support the product. They legally couldn't do much with it because they were precluded from entering the computer industry until deregulated. But the newest version of Unix, called System 5, which is about the 6th version ever released by them in a number of different names, is commercially supported. And although the product still needs to be enhanced and improved for small systems and beginning end users, ATT seems to be making some big strides toward that.
Mm-hmm.
Gene, how does Xenix compare to Unix?
Okay. Well, the Unix software from ATT is sold in two forms. It's actually licensed. Source code license is an expensive, very high cost license that lets you take the software and actually change it or rearrange it or make it different for your specific kind of computer. Computer manufacturers or software companies buy source code licenses, and Microsoft is one of those companies. Microsoft has purchased Unix source code and has fixed it, changed it, enhanced it, whatever, so that it runs on different kinds of microcomputers. It runs on the Tandy System 16, the Apple Lisa, the Fortune Systems 3216. It's rumored they'll be introducing it for the IBM PC XT. So Xenix is just Unix with a few enhancements for personal computers or for microcomputers.
Tony, you have used Unix. I always sort of associated Unix with the PDP mini computer line, and Gene has just told us that it's growing up and down. What has been your experience with Unix, and how long have you used it?
Oh, I guess I've used it about 5 years, which makes me a relative newcomer compared to a lot of the people that have been using it, but makes me an old-timer with respect to the microcomputer users. I still haven't used it, actually, on a microcomputer, which is pretty amazing. As I told you earlier, I do use MS-DOS on a variety of computers. MS-DOS is reputed to be moving in the direction of looking more and more like Unix. You might want to tell us about what that really means. I'm really curious to see what the next release will be like.
Well, it's difficult because so far the most energetic movers and shakers towards microcomputer Unix have been companies not ATT, because ATT hasn't been allowed to. Microsoft and now a few other companies as well are getting into it. We can theorize that ATT will introduce a whole line of computers. They are going to be a computer company that's fairly well established. If they introduce micros, minis, and mainframes all running Unix, we'd have to assume that whether they do it immediately or fairly short term, they should try to offer the commercial features that the user is going to demand. Because right now it costs a lot more for a computer company to support, hold the hand of a beginning Unix user than it does for MS-DOS or a CPM86 product.
Gary, Tony said MS-DOS is moving in the direction of Unix. Where is CPM in this picture?
Well, I think that the influence from Unix has been a very good one in the microcomputer industry, especially around Unix tools, the C language, the utilities, things of that sort. There's also work that we're doing with Unix ourselves in conjunction with Intel, and we'll see some offerings of that sort. So we believe that it's basically that the Unix systems are, for a variety of people, a certain segment of the market is a very important market. We feel also that in the case of CPM and concurrent CPM that there is more of a commercial orientation to those operating systems. So there's a matrix of these operating systems that kind of complementary in many ways.
I get the feeling that when someone buys CPM, they buy it and they do not touch it. They put it on their computer and hope that it becomes invisible to them, except to do the functions they want. I don't believe there's any two Unix systems alike, at least as I last touched base with it, that seems to be modified, used by systems developers, and tinkered with. Does that represent a difference between the two markets for these systems?
Well, you have to keep in mind that CPM86 and new versions of CPM are enhanced and increasingly functional versions of a microcomputer product. Unix is a mini-computer derived product. It's a big system product, and consequently it has 400-some built-in programs that do everything from typesetting to electronic mail to text processing to calendar to metric to inch conversion functions to extensive programming tools. It's a very big system. But it's very modular. It's like building blocks or alphabet blocks from childhood. You can take these blocks and you can combine them in many different ways. So people who buy Unix typically, for example, my Unix computer sitting on my desk, I've extracted from it about 2/3 of the programs because I don't use them. I'm not doing program development, I'm not doing typesetting, and I just keep the parts that I like. And the nice thing about Unix is that it's sort of a do-it-yourself operating system. You can take all of these utilities that are available and make your own little system together. It does take more studying and expertise to be able to do that than with CP/M. It's a harder to understand product.
Folks, we are out of time. Gary Kildall of Digital Research for today, Tony Fanning of HP Labs, and Gene Yates of Yates Ventures. Thanks for joining us, and thank you for joining us for this edition of the Computer Chronicles.
These are very exciting times for creators and users of operating systems, and the future looks very bright. There is a handful of very popular personal computer operating systems. CP/M and MS-DOS are two. Now Unix is also becoming available for micros. The popularity of these systems has spread largely through the work of third-party software developers and hardware designers. On the other hand, there are some thriving proprietary systems like Apple-DOS and TRS-DOS, which are well supported. So there has yet to emerge a standard that the entire industry is willing to endorse. As with the entire computer industry, operating systems development is in a constant state of change. As new capabilities are added to a hardware system, such as hard disks, telecommunication ports, and laser disks, operating systems must be revised to accommodate them. As new hardware designs were incorporated in the 16-bit microprocessor, designers had to create new operating systems to take full advantage of the increased processing power. And now, the new 32-bit microprocessors with increased speed and efficiency are challenging the creators of system software. There will be a continuing and expanding competition at the system level as there has been at the hardware and application level. Some of this competition will focus on creating operating systems that provide application program portability. That is, the ability for application programs to run on many types of computers. In our next lesson, we'll discover the world of application development and program utilities. Be sure and read Chapter 8 in your text, and I'll see you then. I'm Herb Lechner.
Microfocus, creators of visual programming tools for software development, is pleased to provide major funding for the Computer Chronicles, the story of this continuing evolution.